So this is Ruth, and she'd like to talk to us about the recipe for making geek jewellery. What do you get when you cross a freaking laser with a lot of ideas and a good healthy dash of geekery?
Hello, thank you very much. So hi, my name is Ruth, and this is my first Linux conference, so please bear with me, so I'm a total newbie here. But I'm a maker. I belong to our local hackerspace called Canberra Make Hack Forward, and I'm hoping, I think there's a few makers here as well. So my day job is I'm a user experience designer, so I design a lot of things, but they happen to be very intangible. I design services and products that you access digitally. So I need to do something that involves me using my hands and making things. So I thought I'll try my hand at using a laser. So today's talk is about making geek jewellery with lasers. So I thought I'd give you a recipe for how we do this. So things that you need is you need some kind of idea. We're going to transform that idea into some kind of design. We're going to use some kind of software, which is open source software, of course, and we're going to need a laser. So usually I'll start off by sketching. Normally in my day job, we do a lot of sketching on paper, and same thing with lasers. You come up with an idea, put it down on paper, and we're going to scan it in. So what happens next is once you've got your idea, in this case there was a little bird sitting, that's my very first design by the way. You scan it into your particular thing that you're using, and you actually then use a piece of software to actually transform this into something that's into an SVG format. So the software I'm using here is called Inkscape. Is anyone familiar with Inkscape? Yeah, so I'm using it all the time, and it has its quirks, but it's a really good tool, good open piece, open software. But you see on the left-hand side is something that I scanned that particular diagram, and I actually had to clean it up a lot in Inkscape. Now the reason I'm using Inkscape because it's open source, but also because it saves things, my images into SVG, which is what I need to translate that to something to a laser can do something with it. On the right-hand side, it's a thing I thought I'll try something with the word geek in it because I'm a geek, and designers think I'm particularly geeky, but over here, as I think you were saying before me, that I'm not particularly geeky. I like to think I'm still geeky enough. Oops, wrong computer. So once you get a design, you transform it into SVG format, and because the laser needs something that can follow lines of path, you need a laser. Now this laser sits in my garage because doesn't everyone have lasers in their garage? So this is a 40-watt CO2 laser from China, and being from China, it came with this software called Moshi Draw. Now I'm not sure if anyone's familiar with lasers or Moshi Draw, but it's been described on CNC forums as a step above an etch a sketch. So what happened is, fortunately I have a husband who's a programmer, is very good at hacking as well. So he had to hack at this, I think over a 2-year period because we were busy at work, to try to get this to actually run and do stuff without burning the house down. So what we did was it was modified to run G-code using Linux CNC. We also had to upgrade the motos on it, the motor drives, because it just didn't move particularly well, which is fantastic. We've got a laser that's putting out high-powered beams and everything. So what we've done is upgraded, and it allows us to do very smooth curve. And as you can tell from my initial drawing, I had a round kind of diagram right with the bird inside, and that's a curve. So the first time I cut before we upgraded, the whole outside of the jewellery was really jaggedy. Like you can run your finger around the outside and go, ooh, that's not particularly useful or wearable. So once you upgraded, it looked a lot better. So what we also did was 3D print a nozzle that aires this nozzle for this thing, which means it delivers more oxygen to the beam, which allows it to cut more efficiently. And that's cool because we 3D printed that at our hackerspace. So I love the whole lasers and 3D printing. And you can actually get the nozzle on Thingiverse if you've got one of these lasers and do it and try it yourself. Oh, and also had to rewire the mains with this particular thing because it wasn't particularly safe. So here's a laser. Once you've got your particular image, you have to run. So we run a script that converts the diagram into something that this tool, laser, can understand. So it runs using G-code here. So the script just takes my picture and transform it into a set of instructions that the laser's reading. And this is what the software looks like when it's running. So you can actually see it tracing out the image. And here's the finished piece. Among all my other messy bits and pieces, and they're already sitting in my laser. So my laser can take a piece that's up to about this kind of size. You might also notice that it's using cups to hold things because we hack at things really messily. Since then, we've actually modified it to actually hold the pieces up. But what's interesting with this whole process is, and here's a kind of finished piece, what it might look like. And then you make it into, you put some jewellery. So in case I'm wearing one of these, it says geek. Now the kind of process I went through to do this, but I had to go through this extreme learning process, trying to understand how the materials actually interact with the laser. So when I was first cutting, you have to really worry, because this is 3mm acrylic which I cut with on a day-to-day basis, is if it's too thin, that if the joints are too thin, what happens is this starts to happen, right? It flex around. Now if somebody's wearing this every day and it starts flexing around, you might actually start to wear and break. So you have to be really cautious about how thin you can go. So somebody asked me to do this in this very bad way. Do you recognise this sign? Yep, so it's strongly associated with medical fields. So the first time we tried to cut that, this is what happened. Well, it worked in the laser, it looked good. Then I pulled it out and went, oh, it started to break. It was really, really thin. So that was about iteration 1. I think this was iteration 5 when we hit there. It's a lot, so at this stage we actually had to worry about what's strong enough it wouldn't flex. I'm going to pass this around so you can have a look at it. This one's a bit gentle, so I might just pass this one around, have a look at it. So it's a whole design process about how thin can you go, what kind of designs can you do. So I was doing DNA because I love looking at how science and how we communicate science through jewellery. So this, I'm not sure you can see this, sorry, I don't want to switch over to that one because it causes issues of recording. This is looking at a DNA, piece of DNA here. So you can see the designs, there's lots of really thin lines going on around there. And that went through about 6 iterations in a design. And you can see, I'll get you guys to come up and have a look as well. The design subtly changes in how thin and thick things are. And a lot of it is just trial and error. So when I'm laser cutting, I tend to go for it, cut things, and then things break, and I go, ooh. So I usually wear my designs and test it for quite a while, because if you don't, and you give it away to friends, people buy it, and it breaks and isn't very good. So take this Dalek, for example, which it was fine this morning when I put it into my bag, and it's actually missing a piece, this piece. So the original design had the Dalek's plunger coming out that far. So in hindsight, I should have gone, something that thin sticking out from something this big isn't going to last, isn't going to be very wearable. So that was design iteration 1. So this is an example of laser cutting, then hand painting it as well, and made it to a brooch. So I thought, oh, we can do that. How about something 3D? we do have a 3D printer, but I thought it'd be nice to try it. So this is anyone recognise this? So this is a very messy attempt by me, trying to laser cut and paint and then glue things on a bit badly, to see what else we can do. So I'll pass this around to have a look as well. So the whole idea is, you can laser cut, you can make things, and everyone should be making. So I started going, well, if I can do that, what else can I do? So one of my favourite ones is the one up the top, the heart. So that was done by Alistair and I, looking at, because I don't love hearts, it's a bit, I don't know, for me it just doesn't gel with me. And what I love with that is how fine some of that detail can be. Also Linux tux, you have to recognise that. I'm actually wearing little earring versions of it. So the next step with that is, if you can do this, what else can we do with lasers? So I thought, well, there was recently a GovHack competition running last year where you got open data and people hack it and do interesting things. So we thought, well, what can we do in context of science, communicating science, and global warming and climate change? So what we did was we used the Bureau of Meteorology ACON data set, which is so it's open data from the government, and using the temperature data. So what this represents is the minimum and maximum temperatures over the last 100 years or so for each city. So what it is, it's just a simple script that pulls the data and it just samples it every 6 months. I've got some examples here. So the cool thing about this is, I love when kids come up and they touch it and they're going, wow, this is Melbourne. Look how hot and cold it gets, right? A bit spiky. So this is Darwin. Hot all the time. And I come from Canberra, so here's Canberra. So the cool thing is you can overlay them, because they're relative to each other, right? So you can overlay them and actually see what the temperature differences are. So when you're communicating science to children, they can come up and touch it. It's a physical visualization of this data. And you can see Canberra is just, we don't really, our winters are a bit cold over there. I mean, Darwin might be nice for winter. I also did it as earrings, but the scale is incorrect with that. But can you see Adelaide? So there's something weird going on with the data, with the heat over there. We actually thought there was something wrong with the data, and we went back and had a look, but they actually had some really hot temperatures going on, and you can tell by this stuff, the touch of it. So I wore this as a test piece, but it's pretty spiky. So and if I swing my head too much like this, it goes, ooh. So I was in the client site once, I went like that, and everyone's going, why do you keep saying ow? I'm like, jewellery. So we've actually modded the script a bit to reduce the spikiness for those wearing it as earrings. So the cool thing is that you too can make this yourself. This data, the script to do this is available in Thingiverse, and I'm sorry, I didn't put the link up here, but you Google for it, you can find it. It's called Climate Viz Jewellery. So you can grab the data yourself, hack it, make it better, and then you can make your own jewellery. So this is, for example, what it might look like when you're going to do it yourself. The cool thing is find your own laser as well. You can buy one and put it in your garage as well. So using the Acorn data set, which I thought was pretty cool, because it's all about government opening the data and letting people hack at it. Yes. So, if you want to learn more about this stuff, you want to make your own jewellery, you can either go get your own laser, you can find your own local hackerspace, and who's hands up if you're from a local hackerspace? Okay, so find somebody who's got their hands up and see if they've got a laser in their hackerspace, because you can go talk to them and get stuff done. Because I know the Sydney one definitely does, and Canberra, we don't have one, but you can come visit us.
Or is this a fixie one?
Fixie one. Did you get one of those cheap ones, like the China ones that we did? And lots of hacking involved. If you can't get access to a hackerspace, or your hackerspace is still in the process of getting a laser, you could use Pinocchio. So they are based around, I think, New Zealand and US, and you can actually laser cut this in various types of materials as well. Oh, and I forgot to mention is when I try to laser cut, I've been doing acrylic, right? So what happens is my next step was trying to work out what happens if I go to other materials. And my lesson to learn is don't do this, is don't set your house on fire. I didn't, but this is what happened when I tried to cut wood. Can you see that burn bits? Fortunately, I was watching it and we managed to stop it before it actually caught on fire. So I thought I'd learn my lesson and try it again. And ended up with this. So I still can't cut through it. Yeah, so if I instant some nice etching, I just could not get through without burning. So it's obviously I'm still learning how to do this. So if you have cut wood, come please talk to me so I can learn some more. So that's my next step. I'm going to move towards this kind of material. My laser can't cut metal, but I think if your hackerspace may have one that can do it.
Really expensive.
Go to Pinocchio. Investigate. So I think the lesson learned for me is if you're going to do this, don't give up. I know that was, I think, a good year and a bit ago, and that was a few months ago. So I'm just going to keep trying until I cut wood actually get through wood one day. But in the meantime, if you're interested and want to do more with this stuff, please come and check out your local hackerspace or come visit ours. We're running an event tomorrow night and one on Saturday. And we'd love to see your smart crafting things that you're doing or anything interesting you're doing in the hacker maker community. And that's it for me. Any questions?
I just had a question about the acrylic. What happens to the acrylic that you're burning away? Doesn't that melt or leave blobs behind or burn?
That's a good question. You can see this is the finished output. So in between, like the Linux Tux, for example, has gaps in between. The bits just fall out. It is vaporizing bits, and we've got a vent that actually vents out through the shed into the garden. It's got the most disgusting smell, and I'm scared to think what it's doing to people's lungs as well. But a lot of it's because it's quite a fine laser, 3mm laser. I think 0.26mm laser. Yeah, so it's a little bit of vaporization, the rest is just falls out.
What kind of cost are we talking about for the supplies, for the acrylic, and etc.?
Unfortunately, in Australia, this kind of stuff is not excessively cheap, unless you're buying, I think, in bulk. So a sheet like this could cost, I think it depends when you supply. In Canberra, it can cost maybe about $5 or $10 or so.
Dollars, that is.
Yeah, dollars, Australian dollars. I'm not sure that is in US. Usually when I'm cutting something, I stuff up. So for me, a cost of something is, it keep seeing, with this one, I tried to cut all this at one shot, my laser didn't make it through, so this sheet's now pretty much gone. I can use the bottom bit. But if you've got your local hackerspace, they might have spare materials left over, or you can go in the group buy. So what I did was, when the Sydney hackerspace bought a whole bunch of acrylic, we bought some of the excess from them, and we got it fairly cheaply as well. So that's my experimentation. Any other questions?
Did you design the tiles?
No, that's actually open source design from Thingiverse as well. So I strongly encourage people to have a look at it. Share, if you do come design, share your designs, and let people build upon it and make it better. So I think that one was actually based on 2 other people's designs, and they improved it. And I think in hindsight, we probably should have improved a bit more and uploaded a new design. But that's mine. When I have time, I might try that. And can I just say, it's not, feel free, this isn't scary to do, it's actually really, really fun. So please try it and get involved in your local community to try it.
Just on the Thingiverse thing, I was wondering, do you have to make many changes to designs which you get from Thingiverse to work with your particular laser model versus whatever it was designed for?
Usually we might do a little bit of tweaks, because some of the stuff might be, if some of the design's too fine, we'll have to tweak it. But that's where the Inkscape comes in really useful, because with the pathways, you can just move the path around. For example, with this geek one, that wasn't a Thingiverse, that was just one I was just getting font and putting it together. That required me changing this font into a vector pathway and just physically taking each point and just moving it out so it was thicker. I haven't had to do that much tweaking with Thingiverse, so that's good.
So you're just using the G-code extension for Inkscape?
Yep, so using the G-code, which has been a bit buggy, but I think we've added some fixes and uploaded the game, because there's some issues with misspellings or trajectories, because you're going to identify how fast or slow the laser is going to go, how much power it's going to output. But yeah, so that's what we use. I'm also trying to put the eggbot CNC stuff as well, see whether I can make the path more efficient. Because when you're cutting a sheet like this, that could take me about 4 to 5 hours to cut the whole sheet. And when it stuffs up and you don't know till the end, because I'm not there for 4 or 5 hours watching it, it's really disappointing. And sometimes the stuff, the laser just jumps all over the shop trying to laser cut. It's just really inefficient. So I'm trying the eggbot one to see if the pathway is a bit more efficient. So hopefully it should be cutting along that way, right? Sort of down that kind of method. At the moment, I think it's cutting based upon how I place stuff. And as a designer, I just sort of place stuff everywhere and move things around. So if you have a better way of doing it, please let me know.
I was wondering approximately...
Oh, sorry, we just need it for the recorder.
I was wondering approximately how fast does the laser cut through the acrylic? If you just draw like a straight line, how fast can it cut through a line?
Depends on what speed you're doing. If I'm doing it 100%, it will literally go zzz, like that kind of speed. I can up the speed more, but the faster you do, the less chance of it cutting through. So there's a bit of I've got a knob in my laser where you can up the power output as well physically, so you could play with that as well as adjusting in the software and try to get the fastest possible speed while cutting through. But the danger with that is different color laser acrylic actually absorbs the laser beam in different ways, so you actually have to really muck around every time. It's part of the fun. Any more questions?
Thank you, Ruth.
Thank you.